Alright guys, welcome on board. Today I'm going to be tackling this room, which is IDS Fundamentals from TryHackMe. So learn the fundamentals of IDS along with the experience of working with Snort. Okay. Snort is a tool that actually helps you track traffic, if I'm understanding this correctly. You can filter traffic, find whatever package, something that may be out of place, I think. I haven't played with Snort recently, just because I remember I did some modules from the TryHackMe learning path, uh, particularly from the SOC 1 learning path, which is a learning path I have not completed because I don't know, I just like to break stuff instead of actually checking what's going wrong on a particular network or device. I do see that the benefits you would have even as a penetration tester to actually know how the blue team would be taking basically taking note of whatever you're doing because you leave uh, footsteps, right? Digital footsteps on the devices on the network. So yeah, I believe this one has the Snort module. Let's check it out real quick. Junior security analyst intro. Yeah, you see there are some Snort about this tool. Let's check it out what it is. How to use Snort real-time threads, analyze record traffic files, yeah, and identify anomalies. Okay, so yeah, that's a module I tackled long ago. I just want to check if I also did the basics and the attacks. Don't think so, but yeah, this one I haven't, this one I haven't either. So yeah, I mean, I might decide to go ahead and finish that learning path as well. Maybe after I check all the things I've been postponing, right? I want all of the rooms, I mean the learning paths from TryHackMe that I have already completed to be at 100%. This bothers me a bit, So I just want to go ahead and complete whatever it is necessary to actually have them at 100%. Then I want to jump on to the red teaming, right? Because I also have this at 80%. I did not complete this fully. I remember I had a problem with the module, and I remember I didn't try to complete it afterwards. It was regarding some installation, I think, in my Kali machine. It wasn't working properly. So yeah, I also have to tackle that. But as you can see, I didn't know that I had already completed the like 46% of the SOC level number one. But this will be the next one, right? Unless I decide to go for the DevSecOps, which I find also interesting. But we'll see, we'll see. Okay, so for now, what we came here to do is the IDS fundamentals. Okay, so let's get to it. In the previous room, Intro to Firewalls, we studied the role of a firewall, a security solution usually deployed on the boundary of a network to protect its incoming and outgoing traffic. The firewall checks the traffic when a connection is going to take place and denies it if it violates the firewall rules. However, there should be some security to detect the activities of the connection that pass through the firewall and have already taken place. Okay, so if an attacker successfully bypasses a firewall via a legitimate looking connection and then performs any malicious activities inside the network, there should be something to detect it timely. For this purpose, we have a security solution inside the network. This solution is known as an intrusion detection system. Makes sense? Think of an example of a building security, okay? A firewall acts as the gatekeeper, checking the people coming in and going out. There's always a chance that some bad actor will successfully sneak inside and start performing malicious activities. He was missed at the gate, but what if we catch him even after he gets in? This can be done by the surveillance cameras present throughout the building. The IDAs the IDS plays the role of surveillance cameras. It sits in a corner, monitors the network traffic based on its signature and anomaly-based detections, and detects any abnormal traffic going out or inside the network. Upon every detection, an alert is generated for the security administrators. IDS does not act on those detections. It only notifies the security administrators about the malicious activity so they can do something about it, right? So this room will equip you with sound knowledge of IDS solutions. In the upcoming tasks, we will also explore the most popular open source IDS solutions. So learning objectives, types of IDS and their detection capabilities, working of Snort IDS, default and custom rules in the Snort IDS, making a custom rule in the Snort IDS. Can an intrusion detection system prevent the threat after it detects it. Prevent it? No, they can only alert it, right? Yeah, types of IDS. So IDS can be categorized differently depending on certain factors. An IDS main categorization depends on its deployment and detection modes. Okay, deployment modes. IDS can be deployed in the following ways. Host intrusion detection system. Host-based IDS solutions are installed individually on the hosts and are responsible for only detecting potential security threats associated with that particular host. They provide a detailed visibility of the host's activities. However, host intrusion detection systems can be challenging to manage in large networks as they are resource intensive and require management on each host. Network intrusion detection system. Network-based IDS solutions are crucial in detecting potentially malicious activities within the whole network, regardless of any specific hosts. They monitor the network traffic of all the hosts involved to detect the suspicious activities. It provides a centralized view of all the detections inside the whole network. Okay. Detection modes, right? Signature-based IDs. Many attacks occur every day. Each attack has its unique pattern, which is known as a signature. These signatures are preserved by the IDS in their databases so that if the same attack happens in the future, it gets detected by its signature and reported to the security administrators for action. The stronger the signature database of the IDS is, the more efficiently it would detect known threats. However, the signature-based IDS is unable to detect zero-day attacks. Zero-day attacks have no prior signatures, patterns, and are not saved inside the IDS databases. Therefore, the signature-based IDS can only detect the attacks that happened previously, right? And its signatures or patterns are saved inside the database. In the upcoming tasks, we will explore a signature-based IDS named Snort. Okay. Anomaly-based IDS. This type of IDS first learns the normal behavior, baseline of the network or system, and performs detections if there is any deviation from the normal behavior. Anomaly-based IDS can also detect zero-day attacks because they don't rely on the available signatures of the detections but detect abnormalities inside the network or system by comparing the current state with the normal behavior, the baseline. However, this type of IDAs may generate a lot of false positives, marking benign activities as malicious because the nature of most legitimate programs matches the malicious ones. Anomaly-based IDS would mark them malicious and believe anything behaving unusually is malicious. We can also reduce the false positives generated by anomaly-based IDS by fine-tuning it, manually defining the normal behavior in the IDS. And then we have the hybrid IDS. It combines the detection methods of signature-based IDAs and anomaly-based IDAs to leverage the strengths of each protocol. Some known threats may already have some signatures in the IDA's database. In this case, the hybrid IDAs would use the detection technique of the signature-based IDS. If it encounters a new threat, it can leverage the detection method of anomaly-based IDS. Signature-based IDAs can detect threats quickly, while other IDAs can have a high precision overhead. However, it is also essential to consider the IDAs based on several different factors. Signature IDAs can be a good option for covering a small threat surface. Anomaly-based IDAs and hybrid IDs can help detect modern zero-day attacks, which are increasing daily and can cause massive damage to organizations, right? So which type of IDAs is deployed to detect threats throughout the network? That will be the second one we saw, which was network intrusion detection system. Okay, on to the next. Which IDS leverage both signature-based and anomaly-based detection techniques? The hybrid what? IDS, right? Okay. IDS example, Snort. So, Snort is one of the most widely used open source IDS solutions developed in 1988. No, I'm sorry, 98. It uses a signature-based and anomaly-based detections to identify known threats. These are defined in the rule files of the Snort tool. Several built-in rules files come pre-installed in this tool's package. This built-in rule file contains a variety of known attacks patterns. Snort's built-in rules can detect a lot of malicious traffic for you. However, you can configure Snort to detect specific types of network traffic that are not covered by the default rule files. You can create custom rules based on your requirements to detect specific traffic. You can also disable any built-in detection rules if they don't point to harmful traffic for your system or network and define some custom rules instead. In the upcoming task, we will explore the built-in rules and make custom rules to detect a specific traffic. Modes of Snort. Okay, packet sniffer mode, packet logging mode, and IDS mode. Okay, so packet sniffer mode. This mode reads and displays network packets without performing any analysis on them. The packet sniffer mode in Snort does not directly relate to IDA's capabilities, but it can be helpful in network monitoring and troubleshooting. In some cases, system administrators might need to read the traffic flow without performing any detection to diagnose specific issues. In this case, they can utilize the packet sniffer mode of Snort. This mode allows you to display the network traffic on the console or even output it in a file. The use case: the network team observes some network performance issues. To diagnose the issue, they need detailed insight into the network traffic. For this purpose, they can utilize Snort's packet sniffer mode. Okay, then comes the packet logging mode. Snort performs detection of the network traffic in real time and displays the detections as alerts on the console for the security administrators to take action. However, in some cases, the network traffic needs to be logged for later analysis. The packet logging mode of Snort allows you to log the network traffic as a PCAP, standard packet capture format file. This includes all the network traffic and any detection from it. Forensic investigators can use these Snort log files to perform the root cause analysis of previous attacks. A use case would be the security team needs to initiate the forensic investigation of a network attack. They would need the traffic logs to perform the root cause analysis. The network traffic logged through Snort's packet logging mode can help them, definitely. And then the last one is Network Intrusion Detection System mode. Snort NIDS mode is the primary mode that monitors traffic in real time and applies its rule files to identify any match to the known attack patterns stored as signatures. If there is a match, it generates an alert. This mode provides the main functionality of an IDS solution. Okay, so an example would be the security team must proactively monitor their network or systems to detect potential threats. They can leverage Snort NIDS mode to achieve this. So the most relevant use of Snort as an IDS comes from its NIDS mode. However, Snort can be used in any of the above modes depending upon the requirements. Okay, which mode of Snort helps us to log the network traffic in a PCAP file? That would be the second one, right? The packet logging mode. And then what is the primary mode of Snort called? Network intrusion detection system mode. Okay, Snort usage. Start a machine. During Snort installation, you must provide your network interface and range. Okay, you can run Snort normally, where it only captures the traffic intended for your host. However, if you want to use Snort to capture and detect intrusions in your whole network, you must turn on the promiscuous mode of your host's network interface. First, let's start the virtual machine. Okay, Snort has some built-in rule files, a configuration file, and other files. These are stored in the etc snort directory. The key file for Snort is its configuration file, snort.conf, where you can specify which rule files to enable and which network range to monitor and enable other settings. The rule filters files are stored in the rules folder. Okay, let's use the ls command to list down all the files and folders present in Snort's main directory. Okay, so rule format. Now let's discuss how rules are created in Snort. There is a specific way of writing the rules. Following is a sample rule that would detect ICMP packets usually used when you ping a host coming from any IP address and port and reaching the home network. The network range is defined in Snort's configuration file to any port. Okay, once such traffic is detected, it generates ping detect alerts. Okay. Action alert, protocol ICMP, source IP, 88 source IP, source port, any source port. And then when the destination IP is the host net, the home net, destination port, any destination the port, and then rule, metadata, message, signature ID, rule revision. Okay. The details of the components involved in this rule are given below. The action, this specifies which action to take when the rule triggers. In this case, we have the action to alert when the traffic matches this rule. Okay, this refers to the protocol, right? That matches this rule. In this case, we use the protocol ICMP, which is used when we ping a host. And then source IP. This determines the IP from which the traffic is originating. Since we want to detect traffic from any source IP, we set this as any. Okay, source port. This determines the port from which the traffic is originating. Since we want to detect traffic from any source port, we set this as any. Destination IP. This specifies the destination IP to which the matching traffic comes. It generates the alert. In this case, we used HomeNet. This is a variable, and we defined its value as our whole network's range in the Snort's configuration file. And then the destination port, right? This specifies the port the traffic would reach. As we want to detect traffic coming to any port, we set it as any. And then rule metadata, right? We have message, we have signature ID, and then we have rule revision ref. Okay, so rule metadata, every rule has some metadata that is defined at the end of the rule in parentheses. The following are its components. Message. This describes the message to be displayed when the subject rule triggers. The message should indicate the type of activity detected. In this case, we use ping detected. Signature or SID. Every rule has a unique identifier that differentiates it from the other rules. This identifier is called the signature ID. In this case, we set the SID to 10,001. Okay. Rule revision ref. This sets the revision number of the rule. Every time the rule is modified, its revision number is incremented. This helps in tracking the changes to any rule. So rule creation. Let's paste the sample rule explained above into the custom local rules file in the Snort rules directory. First, open the local rules file in the text editor. Sudo vim snort and then rules and then local rules. Okay. Okay, so now add the following rule after the already present rules to the file. Okay, so we're gonna just type in because I like to exercise my typing. ICMP any 127.0.0.1 any, and then the message is gonna contain this. Loop back ping the detect the SID 10.0.0.3 grab 1. Okay, no, we will need the other already present rules in the next stack, so do not delete them. Okay, I'm gonna save this rule. Once you successfully edit the file, press Ctrl X. Yeah, this is for Nano, I use Vim. And then rule testing. Let's first start the Snort tool to detect any intrusion defined in the rule file. For this, we have to execute the following command with sudo privileges in our console. It's gonna be sudo snort -q -l var log snort and then -i and then lo -a console -c etc snort conf. In the key, in case your loopback interface is not called lo, that's what I was just wondering. Replace it with the correct interface name. I think it should have that name because this is a tryhard.me VM. Okay. As this rule is assigned to alert us of any ICMP packets to our loopback address, let's try to ping our loopback address to see if a rule works. Okay, but first, let's wait for this to finish, right? Varlog snort -i lo -a console. Yeah, looks like it's correct. So after we have this, we should be pinging in the local host, and the screenshot below shows the Snort generated loopback ping detected alert when we ping our host's loopback IP. This means that our rule is working fine. Oh, okay. I believe I have to open a new terminal. And then maybe Snort should be listening right now. 7001. And then what if we do that? Okay. So the loopback being detected, that works. Shows that Snort generated loopback being detected, letter looping, or yeah, okay. This means that the rule is working fine. Okay, let's stop the ping. 15 received 0 packet loss, 15 packets transmitted, and a Snort is detecting them. So running Snort on BCAP files, we saw how Snort can be used for intrusion detection on real-time traffic, right? However, you may sometimes encounter a scenario where you have a historical network traffic logged in a file, and you have to perform a forensic investigation to determine any signs of intrusion through that traffic. This traffic is usually logged in the standard packet capture format PCAP. Snort is also equipped to perform detections on these PCAP files containing historical network traffic. Okay, the following command with sudo privilege can be used to perform this action. Okay, so let's try that, right? Sudo snort -q -l var log snort and then -r and then task pcap -a console -c snort snort.conf fatal error, no such file or directory. Should I create it? Replace the task pcap with a path to your pcap file for analysis. What might that be? Where's the main directory of Snort that stores its files? EC Snort. And then which field in the Snort rule indicates the revision number of the rule? Which field? SID, I think. Or was it the rep? No, I think it was rep, right? For revision. Which protocol is defined in the sample rule created in the task? Which protocol? Oh, that would be an ICMP, right? For pin request. What is the file name that contains custom rules for Snort? Okay, so let's check it out, right? Let's go to var log snort log. You're asking what is the file that name that contains custom rules for Snort? Threshold Unicode man communities ID IDS Bcap. Um, that contains custom rules. Like rules folder. Uh, attack response rules, policy rules, scan, other IDS rules. It ends with rules, that's for sure. But what is the file name that contains custom rules for Snort? Okay, I just want to check out what this command used to do. So we saw how Snort can be used for intrusion detection on real-time traffic. Okay, that's good. However, you may sometimes encounter a scenario where you have historical network traffic logged in a file, and you have to perform a forensic investigation to determine any signs of intrusion through that traffic. This traffic is usually logged in the standard packet capture, which would be a PCAP file. Snort is also equipped to perform detection on these PCAP files containing historical network traffic, right? Okay, I understand that now. So I don't think I have that. The following command with sudo can be used to perform this action, assuming that you already have the pcap file, right? Replace the task pcap with the path to your pcap file for analysis. Oh yeah, but right now I'm not doing any analysis unless they let me know that, right? What is the file name that contains custom rules for Snort? The file name, those rules, custom, community, chat, bad traffic rules, stack response, shellcode, SQL rules. How am I gonna go? No, which ones? What? Deletion rules, DDoS, exploit rules, custom or custom. Um, not sure. I'm gonna be honest, not sure. Okay, that's assuming you have, yeah, okay, that's good. But what is custom rules for Snort? Did you use any particular file? Oh, it would be the Snort conf, right? That's where they said that we would have. But what pseudocat snort.com? Threshold expression. Would this be the file? This is the file that contains custom rules, right? Nor.com. But no, that's not the one. So event thresholding or suppression command C threshold.com. Would that be okay? Customize for more, yeah. Yeah, these are all commented lines. Custom normalized TCP. Um, preprocessors. Sure, sure. Okay. Cap. Okay. I can't seem to find that. Specific rules, custom. Would it be custom rules? No. For Snort. What is the finding that contains custom rules for Snort? See if we have anything else here. Uh, goes by the name of rules. It has to go by the name of rules. Means it has to be in this particular directory. Backdoor rules, community info rules, local rules, web PHP. Has to be policy, other IDs, rules, NMTP, ICMP, info rules. No, that's the one. Experimental rules, DDoS rules, custom rules, virus rules. I don't know how to tell that. I want to learn how do I find which is the one that's custom. Let's filter them by date maybe. Let's see what's web. April the 3rd. ICMP. Local rules maybe? This has a weird date. Hopefully this is the one. Okay. Yes, that was the one, guys. Okay. On to the next practical app. Scenario, you're a third-party forensic investigator. Okay, I like that. I like that. A company contacts you to investigate a recent attack on their network. Okay. They handed over a pickup file named intro to IDS pickup, which contained the network traffic captured during the attack. Your task is to run a snort on this pickup file and answer the questions given in this task. Okay, the pickup file intro to IDS pickup is placed in the etc snort directory. You have to change your directory to etc snort and run the pickup analysis command on that new pickup file the same way as we did in task 4. Yeah, that's right. I've seen that file. So let's go back. Let's see where our file is. Okay. So now we have to run a particular command. Oh, which is the command that we didn't write? No. don't mind me, we didn't write it, right? It just didn't run because we didn't specify the correct PCAP file, which we're doing right now. So let's just look for it real quick. Here it is. That's the command. So we're already in the correct folder. What we want to do is just run it using this file, right? This pickup file. So its name's intro to IDS.pickup. Okay, so we're running the command to snort conf. Okay, so you're asking me connection detected. Yeah, okay. The only thing I don't like is that I can't navigate comfortably here because I'm not in my Tmax machine, but okay. It's not that much traffic, so it should be fairly easy. What is really asking me? What is the IP address of the machine that tried to connect to the subject machine using SSH? Well, we can see that, right? Some SSH connection detected. So you're asking me the IP address. That would be, I would guess, which one? TCP from this to this. So it means this is the one trying to connect, right? 10, 11, 9211. Okay, we got it. What other rule message besides the SSH message is detected in the pickup file? What other rule message? Oh, ping detected, right? Do you see that here? Besides the SSH connection detected, there's ping detected. Okay, now what is the SID of the rule that detects SSH? Oh, okay. SID of the rule that detects SSH would be, let's see, I believe I can fly. What's the structure again? Let's check out the structure. IDS Example, Snort. It's not the one. Here, right? Alert. So alert, ICMP. This is the variable. This is any on which, okay, on which board, and then to where, and then you're asking me for the rule, SID rule. This is just the IPs. I guess the SID rule would be here. Would it be this particular one that repeats itself? No, it's not. That's not the one, right? Could be this one because it would be ref. It has 3 parameters, right? Let's check it out real quick. So it has the message, which is been detected. Then it has the signature ID, and then the rule revision, right? This will be the rule revision. This would be the signature ID. So 10 0 0 0 0 2. Is that it? Yes. Okay, that was it with this particular room. That was fun. I certainly like it. To look at files and actually find what happened, and yeah, I do like it. Not as much as hacking a machine, just doing pen testing, but yeah, it was. I can't complain. So yeah, that's it for today, guys. Until the next video. Thanks for staying with me.